Assalamualaikum, my name is Balkis Farzana binti Azmaisha. My matrix number AD 2021. Today I would like to introduce our group experiment. Our title group experiment is Flow Measurement by Orifice Meter. We are from section 6, group 6B. So this is my group members. Muhammad Amirul Arif bin Hassan, Muhammad Syahrul Fahmim bin Syahruddin, Muhammad Nabil bin Sarlan, and Muhammad Nazrin bin Nasrullah. For the table of content, we have the objective, learning outcomes, theory, list of equipment, experiment procedure, results, discussion, conclusion, and reference. Hi and Assalamualaikum. My name is Balkis Farzana binti Azmaisha. My matrix number AD 2021. Today I would like to talk about the objective. The objective of this experiment is to determine the flow rate of the orifice meter and to understand the relationship between velocity and pressure of flowing fluid. The learning outcomes. At this end of this experiment, students will be able to determine the flow rate of the orifice meter, demonstrate and perform the work as a team in carrying out experiments, organize and conduct the task by using appropriate equipment.
Hello, Assalamualaikum. My name is Muhammad Amir Arif bin Hassan. Today I want to explain about theory of orifice meter definition. The orifice meter or plate is the tool used in fluid mechanics to measure the rate of flowing fluid or average velocity. In other words, the orifice meter or plate operates on the tenets of Bernoulli theorem, which state that the total energy at one place equals to total energy at point 2. Orifice meter construction or parts. Orifice meter consists of four parts, that is inlet suction, orifice plate, flow conditioner, outlet section. Inlet suction is The inlet section means the fluid will enter into the orifice meter through the inlet section. Orifice plate is situated between the inlet and outlet, and the plate is used to generate pressure drop that will enable to flow rate. The orifice plate construction, it is thin, having one hole which the water will pass. Flow conditioner is used to increase the linear flow in inlet section of the meter tube. The flow conditioner is installed near the inlet section of meter tube. Outlet section is the pressure of the fluid is being discharged and determined. P1 is inlet section pressure. V1 is inlet section velocity of the fluid. A1 is inlet section area. D2 is outlet section diameter. P2 is outlet section pressure. V2 outlet section velocity of the fluid. A1 outlet section area. CD is coefficient of discharge.
For the experimental equipment, we use inlet and outlet orifice, PC valve, reducer socket, a pair of gasket, my steel orifice plate. Then, we use a plastic tube for our manometer in the experiment, a PVC pipe, screw, washer, nut, and lastly, we use a measurement tape for measuring the value of the experiment.
So for the experiment procedure, firstly we need to set up the apparatus according to the diagram, which is the design diagram. Next, connect water supply to the inlet of the orifice meter. Then, open the pipe so that water can flow through the orifice meter. Next, record the initial value, which is manometer head, H1 and H2. Adjust the angle of pipe water flow according to table 1. Then record the final value of H1 and H2. Then repeat step 5 and 6 for each angle in the table. Lastly, complete the table 1 using the appropriate calculation method. Firstly, open the valve at the apparatus and then open the pipe so that the water can flow through the meter, and make sure to adjust the pipe using the angle given. We can see that water in manometer going up on the left side, and for the other side it goes down. If the water level does not have any difference, there might be some problem on the apparatus. The difference height in the manometer is the value that need to be recorded. The most important thing is the angle of the pipe.
So this is the result from this experiment. We get from the angle of pipe water flow, which is 120 degrees, 150 degrees, 180 degrees, and 210 degrees. We get the water level readings, which is H1 and H2. After we get with H1 and H2, we calculate H1 minus H2 to get the differential of water level, and we calculate the flow rate. After that, using the Bernoulli equation, which is Q equals to A2 CD square root 2GH over 1 minus beta power of 4.
So the discussion is we were able to determine the value for both a variable head and a constant head from the experiment. The flow rate for a constant head system is 3.756 times 10 power of negative 4. The experiment could experience parallax mistakes, among other issues. When taking a reading, the eye must be perpendicular to the measuring cylinder's scale in order to reduce mistakes. As a result of the water in the measuring cylinder not being poured all the way, the volume cannot be read accurately. Conclusion: the process that was reviewed before entering the lab must be followed by the student to calculate the flow rate under constant and varied heads at the conclusion of the experiment. It deviates somewhat from the theoretical value and could be the result of a lab experiment gone wrong. Overall, the group members have succeeded in obtaining the desired flow rate value for the experiment.
For the reference in this experiment, we have a lot of books to make the reference, especially the channel books. Besides that, we use Google and YouTube to help our experiment to be done smoothly.